little bit funky, but we're going to use as much as we can. So today we're going to be talking about slope-intercept form. Linear equations are often written in slope-intercept form, which is the y equals mx plus b. We know m is the slope and b is the y-intercept, or where it crosses the y-axis. And then the xy is going to be a coordinate point on the graph. So if you've been given the equation, it's real simple. Take a look at it. Your slope is going to be the number in front of the x. Your y-intercept will be the constant that has no variable behind it. Same thing here. If there's no number in front, we assume it's 1. So since this is negative x, we're going to assume that's negative 1. Our y-intercept is negative 6. Then we have a slope of 1/2. And if there's nothing at the end, we're going to assume it's like saying plus 0. So we would write 0. We talked about this last week, but if you have y equals 4, that's going to be a horizontal line. And we know that horizontal lines have slopes of 0, and the y-intercept is going to be whatever the constant is. So in this case, it'll be 4. So that's real straightforward, kind of a review from last week. What we're going to go into, though, is figuring out how we can get to these equations, whether we've been given points or maybe from tables and graphs. So if we've been given 2 points, change in y values, so that was that delta y over change in x, delta x, just written out. This formula came out weird, but we know from last week that to find slope, you do y2 minus y1 over x2 minus x1. So if I have this point, 1, 3, and 5, 6, let me get a sheet of paper so I don't have to write too small for you guys. So I know that 1, 3, 5, 6. So I know that's x1, y1, x2, and y2. So what I'm going to do is I'm going to set it up. M equals y2 minus y1 over x2 minus x1. 6 minus 3 gives us 3. 5 minus 1 gives us 4. Okay. So what I'm going to do is, if I'm trying to get to y equals mx plus b, the first thing we had to do was find the slope. So that's what we just did. The second thing is you can use the y equals mx plus b equation to find your y-intercept. So since I was not given a y-intercept, I'm going to use this y equals mx plus b to help me find the y-intercept. So I'm going to pick a point. So let's say I'm going to use 1, 3. Okay, I'm going to use 1, 3. I'm going to plug that point into the y equals mx plus b because I have my slope, and then if I'm using this point, I have an x and I have a y. So 3 coming from the y equals m, I know is 3/4, x, I know to be 1, plus b. So what this allowed me to do when I use this point is it allowed me to plug in every single variable except for the b. So now, final step is solve for b, which will then give me my y-intercept. So I know 3/4 times 1. I'm going to change it over to a decimal just so it's a little bit easier to work with. But I know that's still going to be 3/4 or 0.75 plus b. And then my final step solving for b would be to subtract 0.75 from both sides. And that would give me 2.25 as my y-intercept. So if I know my slope is 3/4, and then I discovered my y-intercept to be 2.25, I can write that out in slope-intercept form. Y equals 3/4 x plus 2.25. So following those steps of finding the slope, using y equals mx plus b, which I picked one of my given points, and then I solve for b after I plugged it in. That gave me my slope-intercept form. So my slope is 3/4, my y-intercept is 2.25. Sometimes you won't have to do all that extra because sometimes you'd be given the y-intercept, like on this table right here. This table, you would just have to find the slope, and then you are actually given your y-intercept. So if I'm looking for slope, it looks like +3 and +1. And I'm just checking +3, +1. So I know that my change in y over my change in x is 3/1, which makes my slope 3. And then, like I said, you don't have to actually do any math to find the y-intercept because it's been given to you. You know you have the y-intercept when your x is 0 and your y is some value. So my y-intercept is 9, meaning my equation would be 3x plus 9. If you look at the next two, you would be back to either using the equation to find the y-intercept after you found the slope, or if you think about it, on tables it's a little bit easier because it's illustrated to you. So you know that when you're going forward or this way, you're going 4 to 6, so that's adding 2, and then 1 to 2, that's adding 1. So if I go backwards, that would give me 0 because I have to do the opposite of subtracting 1. And then same thing here. If I want to go backwards, I would subtract 2, which means I would have a point at 0, 2. So that's actually my y-intercept. You could do that. That way if it's easy for you to see the pattern. But it's just you're choosing, should I use my equation or can I just see that pattern? So I know my slope is 2. And then I just figured out my y-intercept is 2. So that'd be y equals 2x plus 2. Same concept when you get to all these other types of problems. The table, pick 2 points, find the slope, and either see the pattern to get the y-intercept or use those steps that we used before. Same thing with the graphs. When you're reading problems like we have down here, you want to pick apart what is the slope and what is your starting point or your y-intercept. So Annalise is measuring the growth of her tree. It is already 4 feet tall. So we know that it's starting out at 4 foot. So that's going to be my y-intercept. And it's growing 2 inches per month. So I know my rate of change or my slope is 2, meaning my equation would be 2x plus 4. So I picked out my starting point for my y-intercept and then saw how it changes, which gave me my slope. A scuba diver starts 5 feet below sea level and dives deeper 3 feet per second. So 5 feet below sea level. So that means instead of a positive y-intercept, we're starting with a negative because we know if you were right at the surface, it would be 0. So if it's 5 feet below, that's a -5. And then they dive deeper. So they're going down 3 feet per second. So that's going to be our rate of change there. Since they're diving deeper or getting further away from the surface, we know that too will be a negative. So that's going to give us y equals -3x minus 5. Y equals -3x minus 5.